Hi, come take a look at what I've done. Here it is. Isn't it great? This slider is what we'll be talking about today. It's the basis for my sharpening tool's new update. Welcome to deepskydetail. So a couple months back, I wrote what my plans were for Astro Sharp, my Astro sharpening tool. I wanted a way to control the sharpening by inputting a point spread function, to make the stars not as bright when they're sharpened, have some parallel processing to make things faster, and add support for Mac and Linux. Although I've worked on all of these things, I've only been moderately successful. It takes a lot of work to make this tool, you know. I can basically say that I have created an input for this point spread function that controls the amount of sharpening. This has, to some extent, also taken care of point number 2. Getting parallel processing to work has taken more time than I thought, so that unfortunately is on hold. And although I've worked quite a bit on getting things to work on Mac, I couldn't get it to work correctly. However, there is a workaround. It takes a bit of setup, but it's not that bad. The workaround will work for Linux as well. Let's review a bit. I created a neural network that takes a set of blurry pixels and tries to make them less blurry. Basically, I was hoping that the model could smartly deconvolve a blurry image. The way the model was initially trained was that each training image was blurred by a different point spread function. In other words, the model had to figure out how much sharpening should take place without any information about the spread of the point spread function. That worked okay, but it could leave the stars looking weird.
Wait a minute!
Let me go on a tangent for a second. I know I just said deconvolve a minute ago. I actually do not know whether the network is trying to deconvolve an image. I'm not selling this tool, I have no reason to lie about it. When I say I don't know what it is doing, I mean it. Deconvolution is a pretty specific mathematical term. The model is a machine learning algorithm with thousands of parameters. Just like any other AI-assisted sharpening tool, or any AI tool, the actual process is pretty much a black box model. It is nearly impossible to make a claim about what neural networks are actually doing under the hood, no matter how much it costs. So when you use this tool or others like it, just keep in mind that you should double check your results to make sure nothing funky is going on. Okay, sorry about that. For this iteration of the model, I basically did the same thing as the previous model, except I controlled the spread of the point spread function. What does that mean? Well, it just means that I determined the standard deviation of the point spread function beforehand and used that PSF for all the training images. I also added a bit of tracking error and image distortions as well as noise. After training, I saved the model's weights, reset the entire model, changed the standard deviation of the point spread function, created new training images, and trained the model again. I kept repeating this process like 29 times. And that's how I was able to get the slider. Pretty cool, right? I could then use all of those models' weights to control the amount of sharpening. The new version is on GitHub right now. The link is in the description. When you go to GitHub, double check that you're on the right branch. In the top left, it should say PSF beta. Click on the green code button and download the file as a zip file. If you've used a previous version of my tool, you'll notice that there are not as many files, and the executable file is gone. This is intentional. Previous versions were just an Electron app that ran our Shiny app underneath the hood. The Electron app was creating problems. It wasn't opening correctly sometimes, and I couldn't get it to work well with Mac. So I got rid of it. The run.vbs file is now all you need to click. It will open the Shiny app in a modified Chrome window. It may take a while to open, but it should. This is what the app looks like once opened. You'll probably also want Serial opened with the image loaded that you would like to sharpen. Let's open that too. I think I'll sharpen the image of the Veil Nebula I showed in previous videos just so you can look at it for a reference with those previous videos. With Cyril on the right and Astro Sharp on the left, we can start to go through things. In the top left of the app, you can load the image you'd like to sharpen. Just click Browse and choose your TIFF file. The file must be a flattened image with no compression. It should also be stretched. Then you can choose your model. The previous beta versions are still available. They still work. So if you don't like the new PSF model, just don't use it. I would say that the PSF model is in its alpha stage. I think it works okay, but it might not. Because there are a lot more moving parts with this version than the previous two, I really need your help testing it. Give me feedback. It's possible the PSF slider doesn't really add much control. I don't really know. I just haven't been able to test it well enough to know, and I need your help. Okay, so the next set of radio buttons tells the program whether you want to sharpen a black and white image or a color image. If it's a black and white image, make sure it is actually saved as a black and white image. The next buttons tell it whether to sharpen a preview of the center of the image or whether you want to sharpen the whole image. With the PSF slider, you will definitely want to test out different values. It would be a shame if you chose the wrong PSF value, waited like 5, 10, 30 minutes for it to sharpen things, just to see the horrible result and had to do it all over again. Having a small preview will speed up the process. On the right hand side is the processing chunk size. This just tells the program how much of an image should be processed at once. If you're having trouble with RAM, increase the slider, but the default should be fine for the vast majority of cases. The final slider is where the good stuff is. This is how you control the amount of sharpening, well, hopefully anyway. Note that this slider only works with the new PSF model. It doesn't work with the other two models. What we need to do is find the point spread function of our image measured in pixels in terms of standard deviation, or sigma. Sigma is approximately the full width half maximum value of a non-saturated star divided by 2.35. So let's go over to Cyril with our image open and find a smallish round star. Aha! Found one. In the bottom left corner, Cyril will give you the full width half maximum of the star in pixels. In this case, it says 6.71. Let's open up the calculator and divide that by 2.35. We get about 2.85. Let's try that again with a couple more stars just to be safe. Alright, this time I got 2.5 as the final value. And here I got 2.1. So I'd say a good PSF measurement would be around 2.0 to 2.75. Let's head back over to the sharpening tool. And we'll put in an initial value of 2.25. Just note that the slider has a precision of 0.25. I think it's usually a good idea to use the lowest value that gets you good results. So let's start with 2.25. Nothing will happen in the PSF model until after you click Update PSF. Once we do, it will start sharpening the preview. After a few seconds, the sharpened preview pops up. 2.25 gives a good result, I think. The stars look more compact. Okay, let's go to 2.75 and see if there is a difference. Don't forget to click Update PSF. To my eye, the sharpened stars are a bit bigger, with a 2.75 PSF value than 2.25. Although both seem better than the original, the fact that 2.75 PSF is starting to make the stars a little bit bigger might mean there is some over sharpening going on. So let's try 2.5. I still think 2.25 is best, so I'm going to go with that. The final step is to click Full Image, and the program will automatically start sharpening the full image with the options you've chosen. Now would be a good time to watch the Lord of the Rings trilogy, or maybe even read the books. What can I say? The program is free, gosh darn it. Alright, here's the final result comparing the original Veil Nebula to the sharpened version. Now let's do the heart of the Heart Nebula that I also showed in a previous video. First, let's find the smallest round star. Its full width half maximum is 8.45, which means the PSF in sigma is around 3.6. Let's try another star. This time the value is around 3.0. 3.0 seems good for demonstration purposes. I'll go ahead and click full image and let the program do its thing. Have you finished the 2 towers yet? Well, now's the time. Okay, here are the results. It's pretty subtle, so maybe a higher PSF value would have worked better. But I've already read Lord of the Rings a few times, and I've seen the movies, so I'll leave the experimentation to you. Also, if you find the things I do useful, consider subscribing. Alright, Mac and Linux users, I haven't shown you enough love, but I've tried. Really, I have. It's not you, it's me, but hopefully I can make it up to you. I've got a workaround for how you can use Astro Sharp 2. It shouldn't be that hard. As I said, the program is just an R Shiny app. So let's go ahead and download R and install it. R is, allegedly, a programming language. You're going to want to download it. All the links will be in the description. Also, Mac users may have to download Xcorts to make it work properly. I did it. It's easy. Anyway, download the R version that corresponds to whether you have an Intel or ARM processor and install it. Things will be much easier if we also download RStudio too. Trust me. So let's do that. Go to RStudio's website and download it as well. It's free for personal use. The first time you open RStudio, it should find your R installation. If not, you can tell it where it's installed using tools and global options. What we want to do is get the working directory. Type get wd, open parentheses, close parentheses in the console. We're going to change this later. Okay, now go to my GitHub page. Download the zip file like all those Windows users have been doing. What we want to do now is create a working directory for RStudio and put one of those files into it. Create a folder, it doesn't matter where, call it anything you want. I'm going to call mine r_wd for R working directory. In RStudio, click Tools and then Global Preferences. In the General tab, it will say Default Working Directory when not in a project. Click Browse and select the folder you created. Click Apply and OK. Then restart RStudio, as the working directory probably won't change until you reopen the program. Alright, now go to your Downloads folder. Find the folder you downloaded from GitHub. All you need is the Shiny folder inside that folder. Everything else you can delete if you want. Put that folder in the working directory you created. In RStudio, in the right bottom panel, you should see the Shiny folder you put in the working directory. Click on it, then find the app.r file and click on that too. The file should open in RStudio. At the top of the code, it will say something like packages, bslib, do parallel, etc. are required but not installed. You will need to install these packages. Click the install button and wait for the packages to install. You're almost done. In the console, add these lines of code. They're in the description. Install packages remotes and remotes : install GitHub bips-hb neuralnet. Wait for those packages to install. When that is finished, click the green triangle Run App button, and it should work. Well, that's it for this video. I hope the app is a useful tool. Give me some helpful feedback, and thanks for watching.